Hello everyone, I am Marie with Karim Azoum from the French Competence Center, part of the EuroCC project, and with Pierre Aubert from LAPP Annecy. We organize the Grey Scott Thursdays and the Grey Scott School, which is less than 1 month away now. So this is really the moment to register. We're happy to announce that we have now 15 satellite sites who join the adventure across different European countries, meaning even more opportunities to follow the school locally with colleagues and local communities. You have all the information on our website. I will put the link in the chat just after the webinar. And if you like the full immersive experience, there are still some places available in Annecy to spend the 2 intensive weeks directly with the teachers and participants. We even have solutions and contacts to help with accommodation if needed, so don't hesitate to reach out quickly. As a reminder, the school is very flexible. You can attend the full program, register for only a few selected days, follow from one of our satellite sites across Europe, or join fully online. It's available too.
Could a simple chemical reaction teach you how to unlock peak performance on today's supercomputers? Welcome to the Grey Scott School 2026, a free advanced summer school on high-performance computing, designed for professionals from industry, public sector organizations, and academia. From June 22nd to July 3rd, 2026, join us in Annecy, France at LAPP, at one of our satellite sites across Europe, or online via live streaming. All courses are taught in English. You can pick the courses most relevant to you or dive into the full 2-week program. You'll learn the practical behavior of modern hardware and how to write performance-optimized portable code. Week 1 focuses on CPUs, Week 2 on GPUs, covering architecture, bottlenecks, parallelism, memory, and performance analysis. All learning is built around a single challenge, simulating the Grey Scott reaction. Simple to start, yet complex enough to stress compilers and expose performance limits. You'll explore modern tools, languages, and libraries such as C++ 17 and 20, CUDA, Fortran, Python, OpenMP, TBB, Kakos, PyTorch, and more. The school provides ready-to-use container environments for smooth hands-on sessions. Expert instructors from CNRS and CEA guide you with live Q&A and community support on Discord. Satellite sites let you learn together locally without traveling. Want to host one? It's easy with our turnkey setup, sharing the school with your colleagues and ecosystem. You'll leave not only with hands-on HPC skills, but also an official certificate of participation. And you know what? You can start early with 18 Grey Scott Thursdays webinars, weekly from January 29th to June 11th, introducing summer school concepts and new topics. Whether you're an industry professional, engineer, researcher, or student, if you have programming experience and want to push your skills further, this program is for you. Register now at cc-fr.eu and start learning today. Grey Scott School 2026, Europe's leading HPC summer school.
So I'll share the useful registration links in the chat. Of course, if you enjoy these webinars, please continue spreading the word around you. Every share helps us a lot. And today's webinar is from Pierre Aubert himself. It's an introduction to Rust. So I let you with him. Please enjoy and see you soon.
Yeah, thank you, Mari, for the nice introduction. Yeah, I will try to introduce Rust to you a bit because, of course, this year Adrien does not have time for that, so I will try to do my best to encourage you to try Rust and to make you understand also why this is important, why this language is really good, even with its good idea and with bad ideas, because there is bad ideas in Rust as well. And my point is to present to you Rust as a whole. So the good ideas, the brilliant idea in Rust, because there are brilliant ideas in Rust, but also something that are a bit weird and you don't know really well what come up to the developer to do that. And still, it's a really good language. So let me start with a bit of history because, of course, I will compare a lot of languages during this presentation. So it's important to have the full story in mind. So let's start with the first language, as Vincent mentioned, of course, in his presentation, Fortran. Fortran started in 1957, and of course, at this time, nobody was on the moon, nobody was on space yet. Yuri Gagarin, it's 1961. Computation is really, really a small thing, even if it's in really big rooms. And to give you an idea of what's going on this year, we get 3:10 to Yuma, Gunfight at OK Corral, and 12 Angry Men. And 2 years after, we get COBOL. And Here You See Me Come, we get Rio Bravo, Operation Petticoat from Black Edwards, and Sign Arsène Lupin, to cite a French movie. So it's still quite difficult. Computer does not have memory, not computing power. It's quite really difficult to do some programming language. And of course, once you want to program, quite difficult to compile, and compilers are not really a thing right now. It's really difficult. Then we wait 13 years and we get C, 1972. And in 1972, of course, we have The Godfather from Francis Ford Coppola. We have Silent Running, which is the very last movie of Hollywood on science fiction, and they dropped everything after that. And that's why George Lucas was really annoyed after that to make Star Wars, because of course there was nothing left. So he had to build Island from scratch. And L'Aventure c'est l'Aventure, to cite another French movie. Then we have to wait another 13 years and we get C++, 1985. And here we get a bunch of movies, in fact. Brazil, Legend, Commando, The Color Purple, Witness, and of course Back to the Future, with the date really famous in this movie. Now, compiler try to do some stuff, but it's still really limited. And of course, here we are computing only on one core. And there is no vectorization at all, of course. So we try to figure out how to do stuff, and we start to be a trick to get the illusion that the machine can do several things at the same time, but in fact it's several things really quickly in order. So in one thread only. So no multi-thread at all, nothing. Then we have to wait also to 1991 to get Python, which is an old language, in fact, now. And then here we get Lethal Weapon 3, Terminator 2, Robin Hood, Hotshot, The Beauty and the Beast, Thelma Louise, Once Upon a Time in China, and Ricochet, for example. And here you started to know normally this movie. So we still cannot vectorize here yet, not yet, because it was a bit later, vectorization, as Joel reminded us in his presentation of Eve. The very, very first architecture which was capable to vectorize, in the sense that we understand it today, was released in 1994. So it's the Lion King, to be consistent with this slide. So not yet. So here, of course, parallelization is not a thing. Vectorization is not a thing. Compiler cannot do crazy stuff because, of course, we are really limited into what the machine are capable of. So we rely a lot on the developer. And of course, once you rely on the developer can do mistakes and don't have a problem. But today we will speak about a young language, Rust, 2015. And in 2015, we get The Martian, Inside Out, Bridge of Spies, and Spectre. So really recent movie, even if they are 11 years old now. And here, of course, in 2015, we get vectorization. We have a lot of memory. We have gigabytes of memory. And we can vectorize, we can parallelize, we start to have big machines. So for example, in 2012, we get Titan, a machine which is capable to compute at 20 petaflop, which is really a lot compared to all the other machines. So now it's ridiculous because we passed the exaflop last year, but still it was quite a huge path here. So this language is totally different. Of course, I have to precise that once you don't have any resource, you don't think about unit testing, you don't think about contiguous integration and versioning and stuff like this, because it's not possible. It's really not a dream. It's not possible. But of course, for 2015, we have a lot of experience about how to develop a software, how to write software, the good point, the bad point of doing this. And this language, of course, bring all this good stuff here, because all the other was added, of course, but on the fly with news, with new architectures, things like that. Another point important to loop with the presentation of Vincent about precision, the IEEE 754 was not a thing until 30 years ago or something like that. So it was quite recent. Before, it was a nightmare. All the vendors had their own fashion to compute float and stuff like this. And of course, the language has to adapt. Now it's quite well defined. So not the same problem, not the same idea, not the same history, of course. So I will compare all this language, but keep in mind that they are really different. So of course, once I say, okay, this is quite bad in Rust, it's because it's a young language, and what is bad in Python on C++, I don't know. It's because the language were not designed for that at the very beginning, and you pay the price of the backward compatibility. So let's start. So Rust is a system language, such as C++ or C, so you can build operating system with it. You can build a project with cargo, and in C++ will be CMake. It's a really good standard since 20 years, so use CMake, please. Don't use make by hand or stuff like this. Use CMake, it's really nice. You have some tools to create documentation, so Rusty Doc. We have Doxygen, we have Zensical for Python, or this kind of stuff to cite a new comer in town for Python. And if I show you a hello world, okay, we have some println exclamation mark, but okay, it's quite common. It's quite the same idea as stdc out or printf or print of Python. Okay, not that big of a deal. Quite understandable for now, at least. The point is, Rust comes with a lot of project generators. So you have cargo new, and you can say, okay, -- name to get the name of the program and the name of your project, because of course, nobody is using Rust. Everyone is on C++, on Python, on Fortran, or whatever, because this language are here for a long time, as I mentioned just before. So if you want to convince people to use your language, you have to help them, of course. So you bring a whole new world of project generator to be sure that everyone can start quickly to use your favorite language, because it's important. In C++, on the contrary, the language is old, and we have a lot of ideas to make sure that you can generate program with kdevelop, with VS Code, with the editor you want. You have a bunch of stuff to help you already, because everyone is using this language already. So not the same idea here. So let's start with the really brilliant ideas of Rust, and then we will get to we'll see where we will get. So there are some brilliant stuff in Rust. First, the trait. It's really, really powerful. So you can see that as an API contract. So to give you an example, if I get is simple type trait, an abstract trait, I say, okay, this trait, if you implement this trait, you should have a is simple type method in it, and this method should return a Boolean. Okay, so I can implement this trait for an int32 to tell that the int32 is simple, whatever it means, and I can do the same for Shadok and say, okay, Shadok could have its structure, maybe there is some attribute in it. Okay, let's pretend it's complex, so it's not simple, so it's false. Okay, here Shadok is explicit, so I explicitly define Shadok as a non-simple type. And if I want to use them, I can do that. I create my value, value dot is simple type, Shadok dot is simple type, and it's okay, no problem. If I want to use it on a GB, Rust will tell me, okay, the tray is not implemented for the GB, so you have to implement it first, then I can figure out if it's true or false. Okay. And to do the same in C++, of course, you can use concept because they are meant for that, but of course, you don't have to use concept for that. You can use overloading, simply. And you can say, okay, isSimpleType is a function, and I overload the function with an int, with a Shadok. I get my tray for an int, even if it's not really a tray, but it's the same ID. And I can do the same for a Shadok. And it's explicit. It's still explicit as before. It's explicit. If I call it on a GB, C++ will tell me, come on, I don't have this definition for a GB, so not possible. We can do other stuff here. If I use it like this, it's okay, but we can do other stuff. We can do some template. I can say, okay, isSimpleType is a template function now, and I return false if it's a template that I don't know, so for most global usage. And for type that I know they are simple, I can specialize my function with integer, for example, here, to say, okay, for sure my int is a simple type, whatever it means, again. And I can do the same. I can do my assert, I pass the type into bracket, and it's okay, no problem. But with this way, Shadok is implicit. And if I use it on a GB, for example, it's okay. So could be a thing that you want to do, but of course, Rust choose to be in the explicit way. And this will be a leitmotif for the rest of the presentation, of course. And to show you also that generally, once you have one way to do things in Rust, you have 3 ways here in C++, even more sometimes, depending on your imagination. So, of course, could be a bit annoying at the beginning because you have to get used to this way of thinking. So, continuing the brilliant stuff. There is a split between data, the struct, and the method, the implementation. And that's a really good point. Of course, it's in terms of design, if you make sure that you have some data doing data stuff, so for example, load and save, and that's it, you don't want in this data to add some method to analyze them, for example, or to compute them or to simulate them. Of course, you don't want, because you want flexibility. So if you split it and you do other functions to do that, other classes, if you want to do that, it's better for the flexibility, for the long-term run of your program, for long-term maintainability. It's really important. And they force you to do that. Any type can have a trait. So if I create a trait Shadok and I say my Shadok should have a function Shadok, and I can implement the trait for an int32, no problem. Even primitive type could have an implementation of a trait, no problem. So here a static implementation, for example, before it was a dynamic implementation. It's not really recommended, but for really low-level library to deal with data, for example, it's really powerful. So the compiler can prove a lot of behavior, and that's really, really powerful. So you have lifetimes, so it's a new concept. So you know that if you use C or C++, once you are in a block, and you define a variable in a block, once you go out of the block, the variable is destroyed, and you cannot use it anymore. And sometimes could be a bit annoying, especially if you use reference. sometimes the compiler cannot spot the fact that you are not allowed to do that, and return a reference, and the reference is killed, and you have a problem. In Rust, the compiler will notice that it's not possible and will ask for an explicit lifetime to say, okay, I promise you that this variable leaves the time I want to use it. And it's really powerful also. It's quite confusing at the very beginning because it's a really new idea, but it's really powerful. There is also an unsafe keyword. So it's not a bad word. It's just to say, okay, sometimes the compiler cannot prove that what you are doing is right because it doesn't have the whole information. And you can use it to say, okay, trust me, it's working. Of course, if you are lying to the compiler, you will have a problem. But the best way to do it is to not use unsafe at all, of course. I prefer to say, okay, let's try to explain to the compiler what I want to do to be sure that even in my mind, it's correct and it's nice to be sure that there is no ambiguities or stuff like this. So could be hard at some points because you have the bad habit of C++ or C or Fortran, but it's a good point to have. But be prepared to suffer a bit once you start, because of course the compiler is quite annoying on that. But it's for the greater good. And there is also a powerful handling of error. So you have options, result, or panic. So there is no exception in this language, but it's not needed. So you will see that later. So Rust is light also. So there is no constant suffix cast needed, mostly. So if I create a variable in C++, a size t, so long unsigned, for example, I have to precise 0 LU for long unsigned. So I don't have a cast directly inside my variable. Otherwise, I will have an integer, which is a default for 0. And then I will have a cast in a long unsigned int from this integer. Now compiler start to be a bit smarter, but of course happened a lot in the past. For us, it's not necessary. You put 0 and the compiler will figure out, okay, 0 is U64, I is 32, it's okay, no problem. There is no default parameter, so the compiler understands what is a default parameter, but say to you, no, I want an explicit parameter. I don't want a default parameter because, of course, if the default is changing, you are stuck and you don't want. So everything is explicit. There is no function or method overload. Okay. There is no virtual method, not pure virtual, all the flavor of virtual. You don't have any. There is no inheritage. And you have to ask yourself one main question. Does this type implement this trait? And that's it. And you can build everything from that, and it's really powerful. Even if it seems like it's really simple, but it's really, really powerful. So we can make some kind of overload or specialization at some point. So if I get this function, I use type ID, which is the same type ID as the C++ type ID. So it's a unique ID from of any type you get. So you have an ID and you can compare the ID. And as in C++, it's a very bad idea to use it because, of course, it depends on the compiler. So if you change the compiler, you are screwed, especially if you exchange data, stuff like this. Don't do that if you exchange data. You will have a big problem. If you change the compiler, if you change the version of the compiler, you will have problems. So don't do that for exchanging data, but for local check, it's okay. So here I have a template, but the templates are not really the same template that we get in C++. Here, the template, I have to ask Rust, okay, I want a template, but not any template. I want a template which is capable to print itself, so it should be printable. I want a template which has a type which is statically defined to be able to do the rest of the function properly. Okay? And here I can specialize for the i32, so type ID of i32, type ID of t. If two are the same, it's okay. If they are not the same, I can call the other type. So it's not that elegant. It's not as elegant as if it's hidden and the compiler does it for you, but it's explicit. And again, you don't need that if you use straight, but could be nice for some point. So lots of stuff in Rust are nice. So once you have a source file, You can define everything, functionality, functions, traits, enums, whatever you want. But you can also put unit tests in it. And that's really nice because, of course, if you do that in Python or in C++ or in C, you cannot because you don't want to install your unit test because, of course, it's a big part of your project and you don't want to install a lot of tests. You don't want to install them. So you have to get your hierarchy of sources and you replicate the same for test around or in the same, but with a lot of test directory to be sure that you don't install them. In Rust, the compiler is smart and say, okay, it's a unit test, so I don't install it, but I compile it if you ask me to test. Really nice. The default is constant, so it's the opposite of all the other languages. So you don't have to put const everywhere. And that's really important, again, to use const in the other language because it helps the compiler to say, okay, I will read the data, but never write the data. So data will dive in the cache, but never go up again. So you can do a lot of optimization with that. That's why we ask all the students to be sure that once you want to have a fast code, put as many const as you can and should be better. So if I do that, let value is a constant, let mute var is not const. So mute stands for mutable. We had this last week, so and the week before also. So mute is mutable, so it's non-constant if you want. So it's modifiable if you want. So you need to use some mute to all the mutable variables you want to define, but again, it's explicit. If there is nothing, it's constant. If there is something, it's not constant. Quite nice also. You have to get used to it, but it's really powerful. Then we have a to-do macro. Nice to mark the unimplemented feature or cases that we have to have in a switch or match, which is a boosted switch if you want. And Rust encourages splitting your project into a few crates. So it's nice for reusability and it's a nice packet manager. And you have a cargo lock to get the exact version of all the dependency you use for your project. So you can reproduce it. You can, of course, version the lock as we do in Pixie, for example. And speaking of Pixie, of course, if you have a Pixie lock, comes from cargo lock. Pixie is written in Rust, and it's a good idea of Rust, and Pixie does the same. Cargo lock is a TOML, Pixie lock is a kind of YAML, but it's the same idea under the hood. So Rust is a bit concise, of course, because type are really short. Char it's I8, unsigned char is U8, unsigned it is U32, float it's F32, etc. And that's really fun to me because in 72, where machines get particularly no memory, the labeling were really long. So long unsigned int or unsigned char or stuff like this. And in Rust, once we have tens or hundreds of gigabytes in the machine, we get really short naming, and that's really fun to me. Maybe it's just for me, but sounds really fun for me. Then we have the const char star, which is a str, if you want, in Rust. The std string, which is a string, the std vector, which is a vector. Of course, they are not exactly the same. We don't have the same API. We have extra stuff in Rust, but that's the same idea. Function is fn, public is pub, and implementation is impl. And for the pointers and reference, you have the star that we get in C and C++, it's a box. And reference, you can get the classic reference, the ref mut and the ref cell, depending on what you want to do. But my favorite is reference counter because it's RC. And if you are a beginner and you go in Rust and you see RC, good luck to see what's going on. Because at the end you get used to it. But for a beginner, it's you have to read the documentation, right, to be sure that it's okay. But okay. As I said before, Rust is explicit. So once you call a function, for Rust and for C++, if I call a function with a mutable variable, and my function wants a mutable variable, I have to explicit the mute on the call. So I know for sure with this call, the variable will be modified by the function call. In C++, can be modified, but we don't know, in fact, because it's implicit. And For Rust, we have one possible call, this one, and that's it. Otherwise, we get an error. In C++, variable could be const if it's passed by copy, as here, but maybe it's modified if it's passed with a reference. We don't know. We have to go on the definition of the function and get the definition of the function with an IDE, but we have to check. In Rust, for sure, you have the information in the call itself, and that's really powerful, especially if you want to develop some system program, system tools or stuff like this. It's really nice because you don't have to worry about what's going on. You know that you will have a change. Really, really nice. There is no implicit cast, as in C++, for example, so you have to explicitly convert this type into this type with the proper way. The compiler will not let you do that by default. And everything is private by default, so method, function, structure, everything. But the subtlety is it's private on the file level. So inside the file, you can do whatever you want, and once you are out of the file, you have access only to the public stuff. And that's really powerful, and that's because you can also put the unit test inside the same file to check maybe the private attribute of your function or of your structure that you are implementing, to check if it's the right values, to be sure that the internals are right. You can do on the same file, and for the other, it's okay. Everything is nice, and you can use them without problem. Only the public API. So it's quite strange at the beginning, but it's really powerful also. So Rust is explicit in terms of macro, for example. So here it's a macro declaration. So it's a hashtag define of C or C++. And I have my macro name. I can get some parameters. I have my macro body. So I will create a function here. Okay, I have a really ugly bash-like syntax to call a variable with a $. I don't know what's come to them to get that, but okay, why not? That's really specific to the macro here. And then I can call the macro, it's okay. And the good point with that is macro parameters are typed. So you cannot do nonsense or mistakes. For example, in C or C++, once you have some parameters, of course, it happens to everyone. You pass a parameter, you forget to pass a parenthesis. And of course, you have in your macro, you have times b, and you pass a plus 1 and not a plus 1 in parentheses, and you have a plus 1 times b and not a plus 1 times b. And of course, you don't have the right behavior because you forget to pass parameter. Here, it cannot happen because Rust will check for the right types on the macro. And of course, you can extend. Here, I have one possible body. You can extend with a lot of parameter, but it's a bit too much for this presentation. The fun part is the naming. They are really inspired. You have TY for type, TT for token tree, PAT for pattern, ident for identifier, exp for expression, block for block. Okay, that happened. And path for the type path, stuff like this. So you have plenty of types. I'm pretty sure you will use maybe the 4 or 5 first, maybe not the rest, but it's really, really powerful. Then, sometime in Rust, it's subtle compared to all the other language, and sometimes you can get stuck because of really small things, but you have to think with the Rust way. So let's talk about parallelism for a moment. So in C and C++, if I want to do some parallelism, I have my first thread running on the first half of my table, and I get my second thread running on the second half of my table, and everything is nice. No problem. If I do the same in Rust, because I'm new, maybe, I do the same. I get my thread 1, I get my thread 2, and the access cannot be concurrent. Okay. Why? Because there is a lock. That's a bit annoying, because if I do that, I don't have concurrency, I don't have scalability, so let's use only one thread. That's quite ridiculous. But of course, it's Rust, so you have to explicit stuff. So the solution is to use chunks. And you tell the compiler, okay, I will split my vector in 2 chunks. And the first chunk can be used with the first thread, the second chunk can be used with the second thread, and everything is nice. And of course, there is no problem to do the first part. But here, if I do a mistake in my implementation, and for some reason my first thread is using some values here in the second thread, I can have a big problem, but really well hidden. Because of course, this one will start, and only if this one is really late compared to this one, I will have a problem. So it's really, really well hidden. But I do have a problem maybe. Rust will make sure that it's not possible. So it will tell you that, okay, you tell me this is one chunk, you are not allowed to go here for this thread. So there is a problem. So again, we explicit, it's not, you don't have a cost, an extra cost, it's just for the compiler. It's important also to have that in mind. But you tell the compiler, okay, I know what I'm doing, I prove that to you, it's okay, no problem. The rest is powerful also, yeah. Iterators, as Adrien mentioned also last year and the year before, of course, iterators are really powerful. You can have enumerate step by chain, take everything. It's really powerful. It's a lazy evaluation by the compiler, so don't worry, it will cost you nothing. Just compiler will take the whole stuff that you want to do on your vectors and will do everything to be sure that it's okay at the end. But it's nice to have that in mind also. And the same idea for the C++23 std view transform that I presented a few months ago now on the Grayscott Thursday. So you have a look if you want. So zip is working well also. So here in a little example, I have a vec A, vec B for the zip, and I do a zip and it's okay, no problem. So the same idea of the std view zip. So you can get on G++ 15. So C++23 in G++15, otherwise you don't get performances as I presented before. Personally, I do prefer the way of using view transform zip rather than the zip of Rust, but that's just a matter of taste, so I can live with that, no problem. Even if it's really powerful, the zip of Rust is really powerful too. So Rust sometimes is a bit complex, of course. Let's talk about enum. So enum is really simple. It's an integer with named values. So you cannot get wrong. It's really nice. But of course it's Rust. And in Rust, an enum is not really an enum. So let me illustrate that with Shadok, of course. So let's create a Shadok. And I want my Shadok to be printable with a debug print. Okay. Let's create a GB, printable also. And I want to mix them both with a Ruxel, with an enum. And here you see that I have a value Shadok. Inside I have a type Shadok, my type here. And I have a value GB with my type here. So you're not obliged to get the same name, just here for legibility. I get the GB here. Or I have nothing, maybe. It's an empty. And I can use them this way. So I can say, okay, I have a Shadok here. I extract the value here, and I can do whatever I want with my Shadok. I can do whatever I want with my GB. Or if I have nothing, it can happen. I say it's empty. And here you see a glimpse of match, which is the switch of Rust, but way more powerful than a classical switch. So keep that in mind also. I will not go into the detail, but match is really, really powerful in Rust. And enums are trees, in fact, in Rust. So not classical flat enum as in C++, they are trees. So kind of the enum that you can get in Python, for example, once you can mix a lot of stuff like this typically. So sometimes Rust is too powerful, a bit too much, even if it's really powerful, but it's a bit too much. So you can add a trait on a struct by calling what they call a proc macro. So here I can say, okay, I want a default parameter, I want debug, I want a custom macro. And playing that game, you can have comparison, equality, display, argument parsing, data format, whatever you want, because of course you can define proc macros. And the proc macro can change the compiler intermediate representation on the fly. So maybe it will be a bit more clear on the compiler lecture that it will give in the school itself. But basically, you have an intermediate representation of the program, which is a graph, basically, and then you can do everything you want on it. And here, you get a proc macro, you get a graph, you get the tree, you can modify it, and you can send back the modified intermediate representation, and the compiler will do everything for you. Of course, if you have a problem, you're stuck, because it's really difficult to debug, but it's really powerful. The intermediate representation is an enum, because enum are really powerful, as I said before. And try to be really specific once you use this proc macro, because you can quickly increase the complexity of a program and really be lost at some point, because you can do really black magic with that. So it's really, really powerful. But keep in mind that you can get stuck at some point also. And for debugging, it's quite hard. A little problem, which is not really a problem, it's more a feature, it's that you cannot use a proc macro inside the crate, so the package, if you want, the project, which defines it. So for security purpose, if you get a proc macro that is calling itself, of course, you can have infinite loop, you can break your memory, you can make a memory bomb, something like that. So of course, you don't want to allow that. And as my teacher used to say, a compiler cannot break. So a compiler is not allowed to have a segmentation fault, to have this kind of stuff. It's not possible. The compiler is always right, and the compiler should run. So that's a limitation. That's a bit of a pity, but for now it's okay. You can live with that normally. Rust is too powerful, but sometimes it's cargo which is too powerful. Let's pretend we have a project A. And of course, the project A depends on the project B. And the project A depends also on the project C, because why not? And you see me come, both B and C depend on D, because the world is horrible. And that's happened. And everything is fine, because we are lucky at this time. Of course, months later, B wants the version 1 on D, and C wants the version 2 of D, and you are stuck, and you cannot create your environment anymore, and that's really annoying. Cargo can mix the two versions of the D crate for B and for C at the compile time. So you can take some part of D with the version 1 to compile with B, and some part of D with the version 2 to compile with C, and it's okay. That's the magic of the compilation. Of course, it's work only with crate on crate.io, but still, it's really powerful. It does not work with a Git project, it does not work with a local repository, local path to a repository, but still, it's really, really powerful to have this kind of stuff. It's the only example I have for such a powerful project to solve this kind of problem. So yeah, really powerful. For if you did some Python at some point with NumPy, with maybe AstroPy, with I don't know, PyTorch at some point, they disagree on the version of NumPy and you are stuck. And it's horrible, and it's really, really, really horrible. Here, it's solved. It's really powerful. Let's talk about some traits now. So we have CRD, stands for serialization, deserialization. And to use it, you can just define a struct, and here you are capable to serialize and deserialize, so read and write JSON, TOML, YAML, everything which is supported by the sub package, the sub crate. So really powerful. So I use only deserialize here, and then I can call on a TOML, so name, age, for example, because it's a Shadok, of course, and I can do TOML from strarray. I pass my config string here, and it's okay. It's really nice. And you get the parsing error for free, you get the missing values for free, you get the misspelling, you get the wrong type, so everything goes for free. So the only thing you have to do is to use CRD deserialize, you put that here on your Shadok, and then you can parse your Shadok directly. It's okay. It's really, really powerful. It's a nightmare when it's not working, but big part of the time it's working. But sometimes you can get stuck and it's horrible. But when it's working, it's really, really, really powerful. So of course, we can do the same in C++. So we have a file generator for that. So in C++ and in Rust, of course, we can do both. So here could be the equivalent of config stream for our C++ library. You can use check stream, type stream, and data stream for binary types names, value check, and config parsing. But okay, just little glimpse to show you that it's really powerful, but you can do the same in other languages if you know the right library, of course. For argument parsing, of course, that's really annoying. Parsing argument you pass to your program. Nobody wants to do that because it's quite annoying. And Rust does it in a really nice way. The same. Here, it's a bit more complex, of course, because you have to specify for each attribute how you want to parse it, if you have a default value, stuff like this. But that's quite the same idea. And if I want to use my Shadok, I say Shadok parse, and that's it. And I get again all the problem, all the error for free, and it's okay. It's really powerful when it's working. It's a nightmare when it's not working as for CRD. But most of the time, when you know the edge cases of this, it's really, really nice. So we can do the same with the Phoenix option parser for C++. Even if I do prefer the Rust way, because I found it really simple to see, and it's really clear that this is the struct that will be parsed and not the rest of the world. So it's really nice. Here you can have more flexibility, but maybe a bit confusing sometimes, depending on how you use it. But both have bash completion. Even if I struggle to use bash completion of Rust, it's working. So bit of work, it's working. For this C++, it's by default, so you have the bash completion by default. But for the other, you work a bit, but it's really nice. Of course, you have the famous argparse of Python, which does the same, which is a bit slow sometimes, but does the same also. So don't reinvent the wheel, use what's exist, and it's really really nice. So sometimes Rust is not good, not bad, but middle of the middle. So as I said before, that's the most annoying compiler you will ever use for all your life. I promise that it's really most annoying compiler you ever used. And conventions are not convention at all. They are rules. They are really, really rules. And naming convention for variable, parameters, function, method, source file, directory is netcase, and that's it. For structs, for enums, for trait is camel case, and for constant is rhino case. And that's it. Normally, you can change if you want, but be prepared to have thousands of warnings if you do that. So you can change, no problem. But we'll have thousands of warnings, and at some point you will have also a really long configuration tunnel, and you don't want that just for this kind of stuff. So use the convention that Rust wanted you to use, and that's okay. So for cargo, it's the same. Sources are in src dir. Main is in main rs. Library is in libs rs. Test is in test directory. And that's it. And if you don't respect this convention, nothing will work. Or you can also write a 1,000-kilometer tunnel to explain to Rust, okay, I want this, that. No, use the default and use it properly. It will be much simpler. There is a mod keyword, which is quite the equivalent of a CMake add subdirectory, but it's the middle of the sources. Strange, but it's only for this one. Okay. Or strange, but why not? And the return keyword is not mandatory, so it could be really confusing for beginners. So this is totally fine. I return 42. It's okay, no problem. Of course, this is the equivalent of this one. No problem. And that's quite confusing at some point because, of course, you are not searching a return keyword anymore, but you are searching a missing semicolon at the end of the line because of MATLAB, because why not? Why they copy that? It's so ridiculous, but okay. So be prepared if you are stuck on a really long function to have lots of problems. If you pick in CLAPP or in CRD, for example, you have 400 lines functions with all this weird stuff inside. Good luck to see what's going on and which version, which variable is returned. It's a nightmare. So do that only for small function, please. Otherwise, you will have a problem. So I don't know why they come with that. So there is no header. At some point, you can say to me, okay, I use Python all the time. There is no header. What's the point? Okay, but I use C++ and I like to have headers. And of course, you need to dive into a full source file to see what is exposed. Or you don't have a header to say, okay, I expose this function and this function, and the rest is my internal stuff. Don't look at it, okay? But here it's in one file, so you have to search for the public keyword in it to get the information. That's a bit annoying. You have to get used to it. Now I'm used to it, but yeah, at the beginning it's quite annoying. Of course, you can refactor. You can say, okay, put only public members in one source file, only private members in another source file. I can maybe use a prelude. So Adrien mentioned that also last year for the lecture in Rust. So you can use a prelude, and then it's a special module. And if you use it in a crate, you get all the essential functionalities that you want to have to use this module properly. So it's nice also to have this kind of stuff, but of course it's an extra work for you to develop this package well. But if you have a good idea, it's okay. If you use Z, for example, it's okay. You can get at once what is public, what is private, and you can have a completion, and it's okay. So not really a problem, but you have to get really efficient IDE to be sure that it's okay. The rest is not C++. So if I declare a variable that looks like this, if I declare a variable in Rust, it's not the same. Int var 0, let mute var u32 0, not totally the same. If I create a shadow on C++, I get my stroke shadow. The first is the type and the second is the name of the attribute. Of course, Rust is the opposite, and you get comma and not semicolon. And that's good. You cannot copy paste C++ from Rust on Rust to C++ or the other way. You have to think again and tell, okay, is it relevant? Do I really want to do that? And that's really powerful. You cannot imagine the number of hundreds of hours are lost because my colleague pick some C++ or Python and mix them together because it's a matter of comma. You add a semicolon, you remove a semicolon, and that's it. But it's not working, but it compiles, so should be okay. No, please, don't do that. It's not possible. That's really nice. At least for me, it's really nice. Because I prevent all my colleagues to do the weird stuff like this, so it's really, really powerful. And it's avoid a lot of mistakes, of course, because you are forced to rethink about your design. Of course, you don't have the same functionalities also, as I mentioned before. So you have to think twice, and it's better. It's really better. So sometimes Rust is a bit pretentious. I have to address that, of course. A lot of people present RustyDoc as a better tool than Doxygen, but please, RustyDoc does not 1/100th of what Doxygen does. There is no call graph, no calling, no color, no include, no trait use. There is, of course, it's a really young project, as I said before, 11 years old. So you cannot have all the functionalities, really nice functionalities that you have with Doxygen. But please, come on. You get some cryptic error if you document your code with tabulation. I tried. Okay, I'm a bit sassy, but I tried, of course. You get an horrible error because why not? It's just a blank character, please. We are in 2026, please. I want to use a blank character in my documentation. So if you create your docs, you can crash your CI, of course, because the documentation is testing the same way when you use test. And sometimes you can crash your CI because you have a tabulation in your documentation. So, okay, it's a bit too much. You don't have a main page. The index.html is not generated by the documentation itself. You have to do it yourself because why not? The whole world is yelling at Rust developer to say, oh, come on, please give us an index.html, please. No, they don't want. Come on, give us an index.html, please. That's so ridiculous. Okay. The documentation of the documentation is really bad. If you never tried Rust, good luck to find how to write the documentation properly. Of course, everyone will say to you, it's okay, it's simple, but there is no documentation example generated from Cargo. So as I said before, Cargo will generate simple project. So for main, for libraries, you get, even in the libraries, you get an example of the unit test. So it's really nice, but you have zero documentation, zero doc. So you don't know how to write properly your documentation commentary. And that's quite annoying. Of course, it's just Markdown, but come on, there is 1,000 of flavors of Markdown. So which one? And you have also specific Markdown because you can use URLs to link with the correct content. That's really powerful, but of course you have to find that by luck. I found that by luck in the documentation because the documentation is really sketchy, quite difficult to read, but you find some important information sometime by luck. It's happened. There is no exception, as I said before, but you have options, you have results instead, and you are forced to handle correctly the result type. But sometimes you are lazy, and you can be lazy. You can use question mark. So basically, you forward the error on link to the caller. So you have an error, and you say, yeah, but okay, let's move the error on the caller, and say, okay, that's not none of my business. Deal with it, not me. It's a bit lazy, but it's really powerful for IO implementation. But if you use them everywhere, you will have a problem at some point. So Rust is a liar sometimes also. Maybe the community is a bit young and they try to make some noise. And okay, just Rust is really a really good language, but come on. Rust is safe. Yes, but a lot of crates are wrapper of C, C++, even JavaScript libraries, because nobody wants to develop them again. So you get sockets, 0MQ, HDF5, you get Plotly, for example. It's a JavaScript library. There is no Rust in it. You need to have an embedded browser in it. That's so bad. So yeah, no, it's not safe. It's safer than C++, but it's not safe. Come on. Cargo is the only builder you need for Rust. No, unfortunately, I would say. If you use MDBooks and you want to compile MDBooks, you need AutoTools. So if you don't know, now we have CMake since 20 years because CMake is a standard. It's really powerful and it keeps evolving and keep being more and more powerful. Before we had only Make, and before we get AutoTools. And they should have died since 20 years, but they are still alive apparently. And they are in MDBooks. Okay, nobody is perfect, I would say. Rust developers always deal with error well. Of course, developers are humans make mistakes. So practically all examples of the Rust book do not have the error handling well. They use unwrap to skip the error handling because you can, unfortunately, in Rust you can. And so 90% or 99% of the example you will get in a Rust book, so the equivalent of C++ reference for Rust if you want, do not handle error correctly. So it's a really, really bad example for you if you want to learn Rust from this documentation. Of course, it's not the goal of Rust book. Rust book is a C++ reference if you want, and you cannot learn C++ with C++ reference. It's impossible. You cannot understand what is a concept with C++ reference. You need to have a proper lecture for that, a proper course. So, of course, now we have some lectures for Rust. It was not the case when I started, so of course it was a bit difficult. Now it mitigates the problem, but really make sure that you handle error well as it's supposed to be in Rust and not the easy path with unwrap. You will have a problem at some point. So Cargo is package sharing, as I said before. It's a really good point, but sometimes people are not reasonable. So if I take, for example, Cargo Tarpaulin, there is 191 dependency, which is a bit too much, of course. And as a developer, you have to think every time you use a dependency, maybe you have a problem because maybe the dependency will die at some point and you have to figure out what to do. If you have particularly 200 dependency, if you have 10 dependencies which are missing, what do we do? Maybe there is a problem, maybe not. You can have a big problem at some point. And the whole problem also, if you have many dependencies, is you will recompile the whole world each time. That could take time also, and that's maybe not a good point. So be careful, or for all the languages, not for Rust, for all the languages, every time you have a dependency, think, okay, do I really need is this dependency? Is it well maintained? Does it have a community? Stuff like this. So sometimes Rust is horrible, especially when you start. And it's important to address that because, of course, maybe a lot of you will start with this webinar, I hope. So be prepared. Rust is explicit. So there is no equal operator for string and for vectors. You have to use clone. And of course, you have the bad habit of C, C++, and Python. You use equal operator, and that's it, no problem. You don't have it. So you have to rethink and say, okay, I cannot do the equal, I have to do the clone. And of course, every time you use a clone, you say, okay, but I have a copy. Do I really want a copy? Maybe I want a reference. So makes you think differently. So that's a pain, but it's necessary for you to be a good Rust developer. So play the game and you'll be really nice. But at the beginning, it's quite annoying. The borrowing can be really a nightmare once you start because it's they say it's a borrowing, but it's not really a borrowing. It's a stolen of ownership. So it's you have a variable, you put this variable in another variable with an equal operator, and of course this variable does not have clone. And so the second variable will stole the ownership of the first variable, and you cannot use the first variable until the other one died. And sometimes it's really annoying. It's really powerful because it prevents a lot of mistakes, but with your C++ reflex, we'll have a problem. So be prepared. Be prepared to start having some trouble. So to illustrate that, if I want to have a C++ strings and I want to do S1 plus S2 plus S2, I can do the same in Rust. And it will say to me, yeah, not a big deal. I have a reference. Okay. And what? Yes, only reference. But the first one cannot be a reference. So if I want to do S1 plus S1 plus S2, I have to clone explicitly the first one for some reason, and then I can use S1, S2 with reference, no problem. I can also use format, which is quite useful, in fact, but it's quite old-fashioned, of course. It's the sprintf C concatenation function, so quite old, but powerful, still powerful. So really nice. But yeah, in fact, I use a lot of format now because the other way is so annoying. But okay. If you want to debug a unit test with Kaggle test, good luck because it's quite difficult. It's really, really difficult. You can use an ugly environment variable to get all the trace, but yeah, not really simple. It's really verbosy, but there is no coloring, no highlighting, so you get blank output, and then you say, okay, but what is the thing which is mattering? Of course, it's a young language. Of course, C++ had a lot of time before having some coloring in its error, stuff like this. But yeah, quite annoying for now. And the coverage report is ugly because it's tarpaulin, and tarpaulin is horrible. So let's have an error stack, for example. You can have this kind of error stack if you have a panic somewhere in your program. That happens when you develop, it's normal. But come on, no such file or directory. Which one? Please. It's supposed to be a recent language. Please, when I have no such file or directory error, I want to have the path. Come on. And this problem is a problem of the developer, in fact, because here I used question mark. And once I use question mark, I don't get the information. Because if you are lazy, you will have a problem at some point. So let's try to use the full backtrace to see what's going on. And I will get this one. And this is interesting because the first part you don't care about. It's none of your business. It's Rust stuff. Okay. The last part is none of your business too because it's Rust stuff. And your business is only this one. So that's really interesting because it's not the crazy reverse stack, stupid reverse stack of Python, but it's still confusing because you don't get the last part is not your business as in C++ or in C or in Fortran. It's in the middle of your stack because why not? So yeah, a bit of work to be sure that everything will be better here. But again, it's a young language, so it's normal to have this kind of problem. But be prepared if you want to debug. Normally, you don't have to debug much because you think a lot once you're writing Rust, but if you get a problem, quite annoying. So sometimes Rust redefines stupidity. Could happen. It's important to address that also. If I use that, it's perfectly possible. Yeah, but what is the type of var? I32? I16? Don't know. It's 0, but which type? Don't know. And type of res? Not really explicit. For an explicit language, not really explicit. Okay. Sounds like C++ auto. So you don't know what you are doing. You have an auto and the compiler will figure out the type for you. Okay, nice, but I don't know the type. So what should I do? The compiler is aware, but not me. It's quite annoying. And by the way, of course, it's a shadow because it's my webinar. So it's obviously it's a shadow. And parameter and variable are not coherent, unfortunately. So as I said before, it's really nice. You have a variable you call a function, and you have explicitly a mutable variable, and it's really nice. But of course, it's really nice for variables. And for parameters, no. It's not coherent. Because of course, a parameter and a variable is not the same, of course. If, maybe another point, if your variable here, if your parameter here is a struct, and you want to use an attribute here, it's behaves like a variable here. So you have to have the mute reference. But if it's a full variable, the full parameter, you don't have. Okay, strange. So could be confusing also when you're starting. So be prepared also for this weird stuff. Not really nice. And we don't know, of course, here if the other function modifies the var or not, because it could be constant, it could be not constant, the same call. So it could be confusing if you say, okay, it's a nice idea, but here you don't get the information. Too bad. So let's talk about Nowaday for a moment. So to reloop with the presentation of Sébastien. So Rust forces you to initialize variables, which is a really good point because, of course, you prevent mistakes. You don't have random values. You get really nicely initialized variables. But if I use NUMA, so to remind everyone, NUMA is what you have on a cluster, basically. Once you have a blade server, you have, for example, 2 CPUs, and you have one CPU with a NUMA node, one other CPU with another NUMA node. So NUMA stands for non-uniform memory access. So the idea is to be sure that the whole CPUs can see the whole memory of the blade, but with some penalty at some point. So if I have a thread doing some stuff with memory on the first memory, it's okay. If I have another thread doing some other stuff with another memory, it's okay. And if I'm not lucky, I get a thread which wants to access the green value, but the green value are the other in my node, and I get a really big penalty, more than a factor 2, sometimes even more. So as Sébastien explained in his presentation on the memory, so be prepared also to have some problem. Of course, life is good, so the operating system does a lazy allocation every time. So if I have a lazy allocation of thread 4 here, and I have a first touch, so the operating system will give me some pages on my first touch to say, okay, you have a segmentation fault, but it's my fault, I give you some pages. Okay, no problem. If I have another thread having a first touch on the other node, it's nice. I have a first touch, no problem. Everything is nice. Everyone is lazy. I am lazy. The compiler is lazy. The operating system is lazy. And everything is working. We have nice performances, and it's okay. Of course, if you are using Rust, Rust forces you to initialize your variable. And of course, you will have the same problem as before. So, okay, you don't have performances. And I'm kidding, of course, because it's not in the scope of the language. And you can use type, which is, the name is wonderful. You have a variable type, which is called maybe uninitialized. So it's a vector of value, but the values could be uninitialized. So that's exactly the type of things you want to do for this kind of problem, but it's not really in the scope of the language for now, at least. So it will come, of course, at some point will be more mature, but for now it's a bit of a trick, but it's to remind you also how Nowaday works. So Rust is not finished yet, of course, because it's a young language, and C++, Fortran, etc. keep evolving all the time. So, of course, so there is no library right now. So it's supposed to be an ongoing work, but for now it's not possible. It's not possible. You can create a library with a C interface, but come on, if I create a C++ library, it's to have a C++ interface. If I create a Fortran library, it's to have a Fortran interface. If I create a Python library, it's to have a Python interface. So if I create a Rust library, it's to have a Rust interface. Please, come on. So for now, it's only static linking. So we link only on GCCS and libc. So traits are just configuration if you want. We have to recompile the whole world every time you compile, but that's really powerful. This makes the trick with dependency, which are not, we disagree on the versioning, that works because of this. So that's trade-off. And of course, if you have some problem with the versioning, it's better to have this kind of stuff. But could be quite annoying to recompile the whole world for a big program. Could be long and quite annoying. So in terms of compiler, in C++, we have a bunch of compilers. We have G++, COMP++, DPC++, NVC++, NVCC, you name it. No problem. In Rust, we have Rust C, and that's it. So if there is no more Rust C, or if Rust C cannot do some stuff, or cannot handle this kind of error, or cannot have the proper feedback, you are stuck. With C++, you can change the compiler. With Fortran, you can change the compiler. With C, you can change the compiler. And since all the compilers are different, and don't say, okay, this is a warning, this is an error, or maybe I have an extra warning or not. You can, by checking a lot of compilers, say, okay, my program is nice because everyone agrees on the program. Here you have only one bell, so one bell sound. So quite difficult, but maybe it will come at some point. So in terms of supercomputing, it's not really mature for now, even if getting better and better. But yeah, not mature as we can get in C++ or stuff like this. It's more and more important, more and more powerful, but yeah, not there yet, unfortunately, but it will come very soon. And for GPU computing, it's not really mature also, but I will not spoil, but I have some news for you for next week in feedback of the GTC, but things are coming for GPU computing, but we'll see that next week. So in terms of size, binary could be quite ridiculously big, especially if you have an old version of Cargo, so 175, so 13 megabytes for Hello World here. So quite ridiculous. So it's getting better and better. Again, the community is growing. People are fixing a lot of stuff. So if you get 194, you have less and less extra binary for nothing. So better and better. But to compare, for example, with the same Hello World in C++, you get 33 kilobytes compared to 3 megabytes. Of course, there is a big difference with debugging symbols. 17 kilobytes with O3 without the debugging symbol. Even if with debugging symbol is better. So of course, a long way to go to get the same quality, and you can use a 15-kilometer long command line to get a binary only 25x bigger than C++. But yeah, I'm kidding. Of course, it's getting better and better. But yeah, it's a young language again, so sometimes you can have some problem. So Rust compiler is not really mature at some point, but again, it's a young language. But in C++, you can define this kind of stuff. You can create a type def inside a struct, and that's really powerful. So it's the design of the std vector. So I stole the design of the std vector, but we can do much better than this. So here I can say, okay, I have a std vector of some types. I can call a shadow of some types and data. So I get directly the container with the right values here, the right type here. So what do I want to do that? For flexibility. So I don't have to do a lot of duplication to put std vectors everywhere, quite annoying. And of course, you cannot do a type def with a template by definition. It's not possible. And if you have something working, but your bosses came to your office and say, hey, it's nice, but I wanted to have this run on GPU. How can you do that? And you say, oh, I have to do an ugly replace of every std vector to a universal vector. But no, here you get to your shadow, You change the std vector to a first universal vector, and that's it, because you plan that and you use the Shadok data everywhere in your program. So if you change, it's okay, no problem. That's really, really powerful. And normally, if you do that, you can do the change before your boss is out of your office, and you have points for that. If you are capable to do that, you are point. So it's really powerful. So if I want to do that in Rust, okay, I cannot create a type def inside of a struct. It's forbidden. Okay, let's do a trait. Why not? No problem. Type def is a type. Okay. So I can do that. I can have my Shadok trait with a type data in it. And then when I have a pshadok of any template type I want, I can implement my Shadok trait here for a Shadok and say, okay, here in that particular case, my data is a vector of t. And if I want to use other stuff, I can. In fact, I prefer this way because it's explicit. I have a trait for sure. If it's not implemented, I will have a proper error. It's really nice to do this way. So even better, up to here, even better. And of course, I want to use type def for my unit testing, for example, because I want to test with integer because it's much simple to see if I manipulate data properly rather than to use floating points or stuff like this. So, okay, no problem. And the problem is I cannot call Shadok data yet. It's impossible for now. I can do that if I create a type def in my unit testing, so not Shadok because it's Shadok, but pshadok, whatever. I can do that in C++, no problem, but I cannot do that in Rust yet. And that's a pity because it's really powerful. And developers are aware of that. And for now, we have to use Shadok as Shadok tray. So you explicitly, okay, from this implementation, this tray, I use data for now, but it's a bit heavy. And of course, here it's only one time, but imagine you have some pyramids, you have some times, you have some stuff like this, as we will see at the school. That's a nightmare. And the developers are aware of that, and they are working on it. So at some point, we will be able to do that. And that's really powerful, but not for now, unfortunately. But this will come for sure. They are working on it. There is an issue. So they are working on it. But of course, it's not trivial because if you have several threads and several threads define the same name for the data, you should raise an error saying, okay, I don't know this one, will tell me which tray I want to use, stuff like this. So of course, it's not trivial to do. That's why it takes time, but it's really powerful. So you will tell me, okay, so why Rust? Because of course, I'm here to tell you that try Rust. Please try it. It's really powerful language. But maybe Rust is not your main language for developing, and your boss will say, "Oh, okay, come on, it's we want to deliver something in C++, in Fortran, in Python, whatever, not in Rust. So come on." And statistically, I bet that you're probably in this case now. But okay, let's see what's going on. So for Rust, I consider myself, I'm still learning the language. I play with Rust since 4 years now. So I get a bit of experience, but not that much compared to what I do in C++. So it's an explicit language, as I said to you. You don't have much help, even it's getting better and better because documentation getting better. You have a lot of lecture available now, so it's quite better than before. It's not quite mature, especially for what I want to do, so computing, simulation, stuff like this, but it's getting better and better, as I said before. And so for me, right now, it's more that a side language. So I have several projects that I use in production in Rust, but really tiny ones. And the really big part is in C++. So I still have to learn. I still have to practice, of course, because learning is practicing. If you don't practice, you cannot learn, of course. And for C++, on the contrary, I'm experienced. I develop in C++ since more than 17 years now, so I have a lot of experience. It's an implicit language. You have lots of stuff hidden under the carpet, so you have to have big knowledge of the language to be sure that you are fluent and you don't do some nonsense with it. I have an army of code generator to use C++. I mean, really code generator, not random stuff, really code generator that I can trust. I don't have to verify that what is generated because they do automatically the unit testing. it's a production-ready language, and it's our production language in the day-to-day work that we are doing at LAPP. So, of course, at the end of the day, we will deliver in C++ for now, at least for now. So, how do I use Rust, even if it's not my main language? Because I want to use it, of course, because I want to learn it. So what is the trick? So first, you want to ask yourself, what is the quality of what you are delivering? So in terms of design, in terms of implementation, versus the times that you spend on it. It works on every job, in fact. You get what is the quality of you are doing versus the time you need for it. Works in any jobs. So let's pretend that we have already a design, a theoretical design. So we spend an afternoon on a whiteboard with Vincent and Thibaut, and we say, okay, we have to figure out how to do this kind of stuff. Okay. We start the implementation after that in Rust, so to learn it, with the unit testing, with the documentation, basic documentation, but still to mark things and to be sure that it's clear and it's well done. And suddenly we get some information from the Rust compiler itself telling us, okay, this is not really good, this is better, this is, you are not allowed to do that. Okay, so we have to change a bit, we have to iterate a bit, and we improve the design at this point. Naturally, because of the most annoying compiler ever, as I said before, it's a really good point. To make some progress is a really good point. So then we can do the same in C++. And since we have an army of code generator and we have a lot of experience in it, it takes no time to do the same result in terms of quality in C++. But of course, we do have a feedback also because we change the language. As I said before, we cannot copy-paste C++ and Rust together, so we have to rebuild everything from scratch with the same design, with the same ID, but still cannot copy-paste. So we have to rethink about that. And we can have a more mature design here. We can also improve the design, improve the implementation, or both sometimes. It's quite better. But of course, we have a problem here because the Rust is a bit late. So after that, we move again into the Rust part and we make the Rust with the same quality as the C++, to be sure. But of course, if we do that, we have another feedback. We unzoom on what we want to do and we say, hey, maybe this one is better. If we do this thing in this way rather than this way, it's way better. It's more generic, it's more flexible, it's more simple to maintain, whatever. And we can improve a lot again. Not really the design at this point, but still the implementation, maybe a bit the design, but really, really tiny. Then we can update the C++, of course, to get the same one. Of course, we can push the C++ further, very last time, and then we finish with the same quality for Rust. And by doing that, we learn a lot of Rust. Then we iterate on production. And the good point is we get a two-language ecosystem for free. So we have two different libraries or programs which are perfectly compatible together because we re-implement everything. We don't do an ugly wrap of C++ or Rust together. No, we re-implement everything with the real language. And we do have a lot of compatibility between them. If there is data format, if there is stuff like this, everything is compatible. So we are building naturally an ecosystem with that. Typically taking us some days, little small weeks. And that's why we have some blank here because we are discussing, we are trying to improve the stuff, and we are doing other stuff also doing that. So if you say, okay, I cannot use Rust because my boss tell me that it's C++ that we want to deliver, or Fortran or Python or whatever, you can say, hey, we can do the implementation just for fun in Rust, a small implementation, important, and see what's going on and see if Rust allows us to do that. Because of course the C++ and Fortran and Python, they rely on the developer. So if the developer is doing a mistake, that's a feature, in fact, I guess. In Rust, you rely on the compiler itself. And of course, the compiler cannot handle everything. Sometimes you can trick it, and sometimes the error, you can have some problem. But mainly, if you are precise enough in what you do to explain to the compiler what you want to do, the result will be really, really powerful. And if you do the same in C++, we'll have no problem. I guarantee you that you will have no problem. So that's really powerful. So to conclude in a fancy way, if you want, so I will continue the comparison of Gerard Berry on programming languages and music instrument. So for Gerard Berry, C is a piano. So you can use, if the piano is tuned, you cannot make mistakes in terms of notes. All the notes I write, but maybe what you are doing is not music. Maybe you do nonsense, but you cannot go wrong. But sometimes it's not music. On the contrary, if you use camel, it's a violin. So you struggle a lot to have a sound, but once you have a sound, it's a really beautiful sound. But you struggle a lot to learn how to make a sound out of this horrible instrument. But once you can be proud of you if you manage to do that. So to continue, C++, it's an organ. So you have plenty of functionalities. You can have several keyboards. You can play with the feet, with your hands. You can select a lot of plays once you are using it. But if you use all the features at the same time, that's noise. So you have to say, okay, I want to use this and this and this, and that's it. The C++ is the same. If you use inheritance, you use function overload, you use virtual function, you use templates, you use concept, you use default parameter. It's not that you are going into the wall. You are already in the wall. You have to choose. If you do everything, not possible. They are not designed to work together. So you will have a problem if you do that, for sure. So you have to choose. In Python, it's a mixer, so you can mix everything with everything else. And if you want to call a nuclear bomb on it, that's a feature, so it's not a problem. So again, we rely a lot on the developer, so it's not a problem. And if you use a lot of Python or C++ or stuff like this, you know that you have lots of features. And if you come to Rust, the first thing that you may add is, are you kidding? Please, there is no functionality at all. So come on. But I swear to you that in fact it's not this. It's just an impression, because of course in C++, as I said before, you cannot use everything at the same time. So it's not that rich, in fact. And to be fair, Rust is more a horn. You can say, okay, it's really simple. There is only 3 pipes. Come on, it's really simple. No, it's not simple to play horn. You have to know what you are doing. You have to train. You have to be really precise with your lips, with your flow, with your breath. Yeah, that's really not easy. Same for the violin, in fact, if you want, but it's really powerful. And to get the metaphor right, if you want, I can say the 3 pipes are trait, and proc macros. So you say, okay, it's only 3, but it's so powerful. You can do so much things with it. So that's a trick you have to get used to it. I really encourage you to get used to it. It's really, really powerful and makes you do some progress in the other language as well, of course. Anytime you change language, it's better for you. So to be a bit serious, but not too much, and I'm right on time, it's nice. So in C++, you can do everything you want, even stupid things. It's up to you. We rely on the developer. So if your developer do crazy stuff, fortunately, it's possible. So with great power comes great responsibilities. Again, Uncle Ben, every time. In Rust, you can do nothing because the compiler will make sure that you cannot do the weird stuff you want to do because it's trivial to do it in C++, but of course it's not a good idea. So even if you want to do smart things that you think it's a smart thing, you cannot. So you have you are restricted to the good practice, even if sometimes it's a bit too much, but good practice still. And the learning curve of Rust is really slow. You have to fight against it to really improve your skills and to really be good at it. But I swear to you that your design will improve a lot by just using Rust in the proper way. So without unsafe. So give it a try, please. I will say that it's really, really a wonderful language, and you should try it. Even if it's not your main language. If it's your main language, of course, use it, no problem. But even if it's not your main language, use it. You will see that a lot of good stuff will come if you do that. And thanks for your attention. If you have some questions, I will answer them all. Yeah, we are practically right on time. So nice. So, wow. Okay. So Adrien is saying, just for the sake of competencies on the IDE side, Rust has recently gotten its own JetBrains IDE, Rust Rover, after working other while, and had LSP implementation for VS Code style editor. Yeah, but I do prefer Z. Z is really, really good. But yeah, you can use the editor you want, but of course you need a nice editor. So I am telling the second line of defense after trying not to use unsafe is if you do end up having to use it, yeah, I prefer to not use unsafe. But yeah, of course, if you want to, if you need it for some reason, narrow the scope as much as possible by wrapping that into more safe interface as soon as possible. You hide the unsafe and then you do proper stuff on top of it. Of course, you don't want to have the unsafe for all along, but it's better to try. Yeah, could be difficult at some point. I struggle a lot at the beginning because, of course, you want to do things in a certain way, and Rust telling you no, and you say, okay, I don't want to use unsafe because I'm not lazy. I want to learn, and it could take weeks and days before you figure out the right way. But it's better to don't use unsafe if you really want to make progress in Rust. In fact, so again, Adrien, is there other questions? Okay, so I'm supposed to do compensative proof. The next person reading the code, which maybe you in 6 months, will thank you. Yeah, of course. Yeah, it's important to be clear. Once you write your code, you split your function well, you document them well. It's important. As Sebastian used to say, the first person will struggle on your code is you. So it's the you of the future, but be gentle with the you of your future. Write your documentation, use a good design, everything will be nice. Yeah, as I said, macro in Rust is more powerful than in C, so you can overload, you can do a lot of stuff. It's a bit too much for this presentation, but yeah, if you want to do some weird stuff, I have some examples in my Rust lecture, which is not oriented in computing as Adrien, so it's quite a good complementary if you want. So more. My lecture is more oriented on the design, and Adrien's lecture is more oriented on the computing. So if you want to have both, it's nice. But yeah, Rust macro is really powerful. So clap also has an explicit mode similar to what shown in C++. Yeah, but come on, I don't want to be struggle with this kind of stuff. The lazy stuff with the proc macro is really nice, and it's really better. In fact, in terms of design, you have your struct, and this is your parameters, and that's it. And you can pass it to the function you want, and you can use the information. It's really, really nice. One more reason to break very complex function to simpler ones instead of letting them grow. Or maybe for the unit testing, I presume. But yeah, it's really, really better to. Doxygen is nice. Come on, Adrien. Doxygen is really powerful. There is no dependency graph in in fact, there is no graph. That's a bit annoying. The interactive graph of Doxygen, I really miss the interactive graph of Doxygen. It will come at some point maybe, but yeah, I prefer this one. Yeah, there is a lot of dependency in Rust also, yeah, because crates are really small. So you don't have a full C++ library in one crate. Of course, you have a lot of them. But yeah, format, yeah, you can use format this way, but I prefer the other way. But yeah, you can use a format with in the brace. You can put the variable. It's possible. Yeah, borrowing is a nightmare. I know. Oh yeah, I must forget. When I compare the size of the binary, of course, it's static binary for C++, otherwise it's not fair. A question for Henri Pierre. Is Rust mature enough? I'm not sure, but I'm pretty sure it will come at some point. But we have to see. Yeah, it will come at some point. But for now, you have one compiler and that's it. deal with it. I prefer myself to compile with G++, Clang, and stuff like this to be sure that everything is that. But again, if you have a compiler which is really, really strict about what you are capable to do and what you shouldn't do, it's really nice. A question from Yorgos. Is Rust development quickly enough that we can expect it to reach maturity in few months or a few months? I'm thinking it's a bit too slow. A few years, yeah, for sure. In few years, it will be really good. It's still really good. In fact, I can pick this example and that example to tell you that, okay, Rust is not mature on this, on that point, but we don't care. Rust has a really, really strong foundations. And that's what matters. At least for me, that's a really good point for what you can do. And then you can build on top of that more stuff for Crate, for CRD, for Clap, for stuff like this to get much stuff. But the foundation are really, really powerful. And that's really the point. Yeah, the maturity, it depends. Maturity depends how you say it. But of course, I'm doing mostly computing. And computing is not really a thing in Rust. You can do some stuff. You already show some stuff, but with weird stuff, with nightly build, stuff like this. So I don't want to use nightly build for a simple reason. Nightly build, some stuff can be stuck for 10 years. For example, if you want to debug a proc macro, you can do it in nightly build, but it's in nightly build since 10 years. I want something stable, please. So that's a problem of maturity for me. So if you have a feature which is native build to be tested, and then a few months after it's in the main, okay, why not? But 10 years, come on, it's a bit too much. So yeah, it's not, for me, it's not really mature in that sense, even if the basics are really, really, really great. Again, try Rust, please try Rust. It's important. That's the main point of my presentation. Of course, I will not make a 1 hour and a half presentation to tell you that not to use Rust, of course. So use Rust, please. Numerical ecosystem is still generally short, shafted, so I will not expect big news. Small time scale. Or you will have a big news next week, but I'll keep that for next week. A teaser for feedback of the GTC. You will see things come. But yeah, Romain, thank you. Olivier, thank you. Really interesting. I have a good day. Okay. So if you have some question again, don't hesitate. Pass through all the questions. So really do try Rust. Or maybe I can do also some publicity. If you miss the beginning of this presentation or whatever, in 20 minutes, something like that, you will get the uploading automatically on YouTube of the French version of this webinar. So if you want to spread the word to your colleague, but they don't really want to have an English lecture, an English webinar, I have exactly the same of this one in French. So it already being recorded 1 month ago, a bit more. So exactly the same, with the same slides, with the same example, everything the same. So if you want to involve other people that maybe don't want to use to follow a webinar in English, in less than 20 minutes you will have the replay of this one. So if you change the YouTube channel of LAPP on YouTube, LAPP CNRS, you will get also the replay. Maybe an important stuff also, because from question I had in the time before, if you want to start to do some Rust project, really small project, just to see, you can do it several ways. You can say, okay, I want to develop something really small. First small, start with 50 lines of code. Not much, because you will have a lot of warnings. The compiler will yell to you because everything is broken. So small, just to get used to the naming convention, the way you want to call stuff, the way you want to declare everything. So just to get used to, because otherwise you will have a lot of stuff and you will be discouraged a lot. So really small. And then you increase the complexity with baby steps. It's important. The other way, for Sébastien, for example, which is another way, you can say, okay, I have already a little project in C++ or in C or in Fortran. Let's try to make it the same in Rust. So you already have the documentation, you already have your unit testing, you already have the edge cases, and it's a small project. So maybe 1,000 lines, not much. And you can try to replicate the same in Rust, just to learn. And you will see probably that your design could be improvable because, of course, you do the thing in one way and Rust will tell you, no, you are not allowed to use a constant variable and a non-constant variable at the same time. Do a copy, do something, do whatever you want, but you are not allowed. Okay, so you change the design, you change everything, and you will get a really better design. And at some point, you will realize, of course, that maybe you will push a bit and say, okay, this idea is nice in my C++ project, but okay, maybe I can do this way. It will be way better. And you will improve. As I explained before, if you have two projects and you step up like this, you will improve your quality and you will learn at the same time Rust. It's a long way, but in few months, if you do that, I did that every day for 3 years or something like that to get the info. Yeah, I develop in Rust practically every day, but it's important to continue to use it to have the reflexes. And yeah, also another good point maybe for Adrien, when you are speaking about IDEs, I do prefer to change IDE when I change language. So for example, I use kdevelop for C++ because it's the best IDE I can use for my C++ at least. And I use Z for Rust. So I don't have the same interface. I don't have the same reflexes related to this interface. So I don't have a bad habit or stuff like this. If I change, I know that I change language. I don't have the same reflexes. So it could be nice also for you if you want to try another IDE. Try Z. It's really nice. It's written in Rust also, as Pixie, as a lot of program coming right now. So yeah, could be nice if you want to have a look. Okay, maybe if you pretty sure I not forget a question. Okay, so I guess if nobody has a question, maybe we can stop here. Thank you, Georgios. Thank you, Marie. So thanks everyone for coming today for this webinar. Hope you enjoy it. Hope you learn some stuff at least. Next week we'll do the feedback of the GTC as I do every year. So you'll have the news of what's coming in GTC. So in Rust as well, as I teased it a bit today. So we'll have some news with Rust on GPU computing also. So if you are curious, you want to see what's going on, you will have this webinar next week. And that being said, goodbye and have a nice day. Bye. Bye, Lucas. Bye, Adrien.